Hello. All right. Let's see if this works. You know, famous last words. All right. Let's get this going. All right, so usually there's something auto-advancing, and today the thing auto-advancing the slides is me. So the format, if you guys are not aware, every 15 seconds I need to move the slide along. So it's going to be a lot of information. Bear with me, and I think we'll make it through. Just got to give it a second to think. Do I want to show your presentation? There we go. All right. Hey everybody, can you hear me all right? Thumbs up if you hear me okay. Fantastic. Lots of thumbs up. Great. All right, my name is Peter. I am co-founder and CTO at Shipyard, which day-to-day really means some engineering, some managing, wearing a lot of different hats. But today we will be talking about ephemeral containers. So ephemeral containers, we'll talk about what that is in a minute. But first, who is this guy? I flew here from New York City. I was born and raised there. Been writing code for a long time. Been specializing in Docker and Kubernetes for a while. So that's why we're talking about Kubernetes things today. Founded some stuff. I use NeoVim. It's great. And I like soundtracks. If you know Ludwig Göransson, good on you. All right. So what are we going to talk about today? Table of contents, distroless containers, what they are, a problem with them, how do you solve that problem, and when do you use that solution to that problem? All right, distroless containers. So anybody here who builds images, you know that these things can get big. So what you would do is build something and only include, basically, hopefully, your binary, and pretty much that's it, right? So you build these super tiny containers. Those things are called distroless containers. And why would you want to do that? Why do you want to build these tiny containers? You want to build these tiny containers because that means now you're just passing around tiny things whenever you're pulling these images or starting up these images, right? So if it takes a long time to pull or it takes a long time to start up, that is going right into the overhead of running your app, which you don't want. And not only are you going to pull that image faster, not only are you going to start that container faster, but you're also going to save money on storage costs, because chances are you have some sort of CI that's building these Docker images for you, and you're building and saving them on every commit. And so over time, as your developers are working, you're just adding and adding storage costs. So you don't want that, because that is money. And so all these things combined, if you're pulling faster, you're starting your containers faster, and you don't need that much space to store them, that means whatever's orchestrating your containers is going to run a lot more smooth and a lot more stable, right? Because if you're pulling these huge images, they're like 3 gigabytes, 5 gigabytes. Kubernetes isn't magic, as I'm sure we've all learned through all the talks, and it's still going to take a long time to start your app. All right, but one big problem. What is, the problem with this fancy distroless container thing? It sounds great, but the way that you get it so small is you strip everything out. But if you strip everything out, that means you don't have a shell baked into your image. If you don't have a shell baked into your container, how am I supposed to exec into it? How in the world am I going to debug when something's going wrong? Oh no. Don't worry. Smart people have thought of an answer, and the answer, at least in Kubernetes, is ephemeral containers. All right, ephemeral containers, they've been around for a bit, but they just entered beta in Kubernetes 1.2.3. And with that beta came a much nicer CLI interface. You can basically, with ephemeral containers, right? So you have this distroless container. It doesn't have a shell or anything. So you want to get into it and debug something. What you can do now is you can add a container to your Kubernetes pod, right? So instead of taking down the pod and trying to replicate the scenario, you can add to your live running container, your live pod, another container which has all the debug tools that you need, right? And so you have all your tools now, you're sharing processes with the container that's having trouble, you're in the same network context, so you can use all of your tools now to debug this live issue, again, on the actual pod that has the problem. You're not trying to replicate any sort of issue. These ephemeral containers are great, like I just said, for these distroless containers because you don't even have a shell. And so you can attach one of these containers. Now you have your tools, and now you can start debugging. So before we dive into anything, if anybody wants to try out some version of Kubernetes, there's a lot of ways to do it, but I feel like a lot of people are comfortable with VMs, so pop up a VM, run that bash command. Now you have yourself a single node Kubernetes cluster, pretty much of any version of Kubernetes that you want to try. All right, so here we get to the most important slide of this talk, right? So how do you use ephemeral containers? That's your one command, right? That is what you do. You have kubectl set up with your cluster, and you say kubectl debug. On my Nginx pod, I want to start another container. I want to start a busybox container, and I'm targeting the Nginx container itself, right? So the pod with the issue, and then the image that you want to use that has all your debug tools baked in. Right, so that's your command. So now that you have that and you get a shell, now you can start inspecting things. What are the processes that are running, right? So again, they share process namespaces. You can get the full set of processes that are running in your distroless container. You can send signals now to the other processes, right? So you had something running, it respects signals. You can say, hey, reload the service. You can now send the signal from the ephemeral container into your original problematic container. Right, in this case, we're reloading Nginx. Now, again, you live in the same network context, so if there's some sort of networking issue, you can start pinging around, you can start telnetting around, figuring out what's wrong, because again, whatever that network context for that original problematic container is, your ephemeral container lives in the same network context, so now you can just run whatever network tools you have to start figuring out, why can't I connect to this other service? But yeah, that's it. So that's how you use that new command. If you end up in a situation where you need to use your debug tools in Kubernetes and you don't have a shell in the container that you're trying to debug, this is what you would use. We deal in Kubernetes every day at Shipyard, so that's why we're here talking about it. Check out any of those links. We have a mailing list. We have a website talking about ephemeral environments, public GitHub. Check us out. Thank you very much. I don't think I'm taking questions, so right back to the MC.